Hey guys, welcome to 4.5b, which is synthetic division and the factor theorem. This is our last lesson in Unit 4. And what we're going to be doing is, if you recall the synthetic evaluation method, we're going to be using that same technique to divide polynomials. So the synthetic substitution gives the coefficients of the quotient. So it's sometimes called synthetic division, and it can be used to divide a polynomial expression in this form. Of x minus k, where k is a constant. So for example 1, what we're going to do is look at your binomial first. It's always going to be x minus a number. In this case, it's x minus 1. So we want to think about, well, what's the solution to x minus 1? If we were to set it equal to 0, so basically we would add 1 to both sides, and we'd get x equals 1. What this is just the opposite of whatever your sign is. So we know that if we have a negative 1, then we're going to use 1 in our box. So then we line up the coefficients like we did before. So it's 1, -1, -2, and then 8. We bring down our first number, 1, then we multiply what's below. 1 times 1 is 1. Add these, we actually get 0. Multiply those, we get 0. Add those, we get -2. Multiply those, we get -2. Add these, we get 6. Now, we are not looking for this as what we would get out of it, the same way that we did before. What we're actually going to do is look at a polynomial divided by another polynomial, and it's like, what is the result of that? So we get this term, and this term. And they're all going to have a variable except for the last one. So we started with an x cubed. The first term is always going to be the number in front, and then it's going to be 1 degree less than what you started with. So we're going to get x squared. This is the next term, so we would actually get plus 0x. -2 follows that, so it's not going to have an x value. And then the last term, the 6, is going to be plus 6 divided by x minus 1. So what we're doing here is we're dividing polynomials. It used to be a lot more complicated, and with this new method, it's a little weird to start out with this. But if we were to simplify this expression, it would be x squared minus 2, we don't need the 0x, plus 6 over x minus 1. This is our answer to this part up top. When you divide the first polynomial by x minus 1, this would be the result. Okay, let's go ahead and take a look at this next one. Now notice we look at this part first. If it's x minus 7, we're going to use 7 in our box. We get 2, -9, -32, -21. We draw our line, bring down the 2. 2 times 7 is 14. Add these two, we get 5. 7 times 5 is 35. Add these two, we get 3. And then 7 times 3 is 21. And then when we combine these, we actually get 0 for the last part. Now remember what I said. If we started with an x cubed, that means our first term becomes 2x squared plus, now we have 5x plus 3, and then this time we don't, since it's 0, we don't have to add anything at the end. This would be our answer. So if we were to take 2x cubed minus 9x squared minus 32x minus 21 and divided all of that by x minus 7, this is the result, is what we get down here. That 2x squared plus 5x plus 3. Okay? All right, so now let's go ahead and talk about the factor theorem. So in this last problem, our remainder was 0. The last term is always the remainder, this part here. Then x minus k is a factor. It worked out to be a really nice answer with no fractions. That's why x minus 7 was technically a factor, because we could reduce it down to a nice answer. All right, let's try example 3 here. So example 3, again, look at this. What's the opposite of -4? It would be +4. And then we line up our coefficients, 2, -7, -1, -12. Bring down the 2, 4 times 2 is 8. Add these, we get 1. 4 times 1 is 4. Add these, we get 3. 4 times 3 is 12. So again, we get 0. I like to put a colon just to show that this is the last part. It's always going to be the remainder. Since we have a 0 remainder, that's nice because it tells us that we do have a factor of x minus 4. We should get a nice answer out of this. We started with x cubed, which means the first term is going to be 2x squared plus x plus 3. This is the quotient, or the answer we get when we divide those. Okay, I'm going to do a couple more here. Number 4 says solve the polynomial with synthetic division. Given that x equals -4, that tells us that -4 is a solution to this problem. So what we're going to do is, just like with the last one where it was dividing x minus 4, this time though we're going to follow the directions because it tells us exactly what x has to equal. That's one of the roots to this polynomial, one of the solutions. So we are actually going to use -4 this time. We're not going to do the opposite since it told us x equals. Then we get 3, go back here. We're going to write 3, 13, 2, and -8. And then we're going to use 4, or -4. So bring down the 3, multiply -4 times 3 is -12. Add these two, we get 1. -4 times 1 is -4. Add those two, we get -2. And then -4 times -2 gives us +8. So now we get 0 as our remainder. And then the new polynomial that we get out of this is 3x squared plus x minus 2. Now that would actually equal 0 because we're trying to find the solutions. So now we reduced it from a cubic equation down to a quadratic. So we can figure out what the other solutions are. And at this point, there's a couple different ways we could do it. One is to use the quadratic formula, which is the tried and true method. We could also use the other method, which is the cross or the box method. So remember that the top is a times c. So 3 times -2 is -6. And then the b is +1. So factors of -6 that combine to make 1 are 3 and -2. Make our box off to the side here. We get 3x squared, and then -2, and then we use the sides, 3x and -2x. So going up, or starting with the top two, we get x for our GCF, and then these two we get 1. Now going up and down, 3x squared and 3x, we would get 3x, and then -2 and -2x are going to give us -2. So this over here actually factors into 3x minus 2 and x plus 1. And then if you recall from the last unit, or in the last lesson we talked about this too, where you just, for the first one, 3x minus 2, we would set it equal to 0, add 2 to both sides, 3x equals 2, divide by 3, and we get x equals 2/3 for one answer. And then this one here, it's just the opposite, so it's -1. So here's the two other solutions. Don't forget that this was also a solution, but we don't really need to restate it because that was already given for us. Okay, I'm going to do one more problem, and then I'm going to let you guys try example 6 and example 7. All right, for example 5, notice we are missing the x squared term, so we need to rewrite this just to remind ourselves. So we would get x to the third plus 0x squared minus 19x minus 30. And then we have x equals 5, so that's what we're going to use in our box. Get x, not x, coefficients, so it's 1, 0, -19, and -30. Another thing to point out too, if you are given a solution like 5, we know that our remainder has to be 0 if we're doing this correctly. So we bring down the 1. 5 times 1 is 5. 0 plus 5 is 5. 5 times 5 is 25. Add these two, we get 6. And then 5 times 6 is positive 30. So we did this correctly because we ended up with 0 as the remainder. So now we just write our coefficients. We would get x squared plus 5x plus 6, because those are all positives, now equal to 0. And this one works out really well. X squared plus 5x plus 6, those are super nice numbers. So we can factor that out as x plus 3 and x plus 2, factors of 6 that add to make 5. Okay, and then we know the solutions for those, just the opposite, negative 3 and negative 2. So some of these problems are going to work out really nice because you can just get it down to a quadratic. Example 6 should work out really nice. You're just using negative 5. Example 7. Now that one is a little tricky. I'm just going to get you started on this one. So x equals 1. Again, we're missing the x cubed for this one as well as the single x. So you would need to rewrite this one as x to the 4th plus 0x cubed minus 5x squared plus x plus, oh, not plus x, excuse me, plus 0x, because we're missing the x, plus 4. You know what, I'm just going to do example 7 with you. I'm going to make you do example 6. So we would line this up. 1 is the number that we're using. We would get 1, 0, negative 5, 0, and 4. Let's go ahead and synthetically divide this. Bring down the 1. 1 times 1 is 1. Add those, we get 1. Multiply, we get 1. Add those, we get negative 4. Multiply, you get negative 4. Add those, negative 4 again. Multiply, negative 4. Add these, and we end up with 0. So now what we end up getting is, notice we started with an x to the 4th, so this time the first term ends up being x to the 3rd. Then we get plus x squared minus 4x minus 4, all equals 0. Now this is a cubic, so we can't jump to the quadratic equation, and we can't jump to the box method. We need to break down this cubic. But if you recognize this, this is what we did when we were talking about factoring by grouping. So we look at the first two terms, x cubed, x squared. We can take out an x squared, and then in parentheses we have x plus x squared divided by x squared is 1. Now we look at the last two terms. We can take out a negative 4 from both of them, and we get x plus 1 again, which is exactly what we want. Now we can pull these two together in one set of parentheses, x squared minus 4 and x plus 1. And then you have to be able to recognize, I'm going to write this up here, x squared minus 4, this part right here, that's a difference of squares. So we can write that as x plus 2 and x minus 2. And we still have the x plus 1. But now that we have it into these three different binomials, we can solve for these really quickly because it's just the opposite for each of them. We get negative 2, positive 2, and negative 1 are the solutions to this problem. Okay, so your only one that you have to do here is example 6. So give it a try, do the best that you can, break it down, and then use a method of your choice.